with negative numbers. Yes, minus 2 plus 0 is equal to minus 2. It is equal to 0 plus 2. So, 0 plus minus 2. 0 plus minus 2. So, what I can say here, 0 is that number when we add to the given number, we get the same number back. We get the same identity. Identity means the same number appearing again. The same number appearing again. So, you can see here, okay, any number, even if you take 0 also, for 0 also, additive identity is 0. So, always 0 is the additive identity. Additive identity. 4 plus 0, 4. Minus 4 plus 0, minus 4. Minus 100 plus 0, minus 1000, minus 1 lakh. Whatever number it is, when you add 0, you get the same answer. 0 is nothing, right? 0 has no value. It's not, we cannot say 0 mangoes are there in my basket. That means no basket, no apples, no mangoes, correct? 0 means nothing. So when what you're adding nothing to the number, you will get the same number again. For the number 5, you're adding nothing. So the same number will appear. For minus 1000, you're adding 0. That means you're not changing anything. Same minus 1000 will come. Okay. So that is about additive identity. In the same way, we have additive inverse. You can see here, additive inverse. What will happen with inverse? Inverse means the complete value should change. The complete positive should become negative, so that these two will sum up to give you 0. Okay, see here. For the number A, if you add minus A, okay, additive, you're adding some numbers such that you should get 0. You should get 0. For the number 4, I need to add minus 4 to get the answer 0. 2 minus 2 is 0. 10 minus 10 is 0. Minus 1 lakh plus 1 lakh will give you 0. So that means the negative of the number. The negative of the number is called additive inverse. For a number A, minus A is the additive inverse. For the number minus A is the additive inverse. Understand? If I have 10 minus 10, if I have 20 minus 20, if I have minus 1000, 1000. So these two will sum up to give you 0. A plus some value minus A will give you 0. Right? 20 for number 25, you can say minus 25 is the additive inverse, not identity. Inverse means you should get the sum as 0. You should get the sum as 0, right? So for example, 30 plus 0 is 30. Minus 300 plus 0 is plus 300, right? Minus 300 plus 0 is 300, or minus 300 plus 300 will give you 0. So all these are different examples for additive inverse. Simply just change the negative. If you have negative, remove it. If you don't have, keep it. Positive number, you will get negative number. Negative number, you will get positive number. Additive inverse, not identity. Identity means identity should get the same number back. You should not get 0. Inverse means for a positive, you should get negative. For a negative, you should get the positive. Right? That is about additive inverse and additive identity. Next, we will go forward to learn what is a multiplicative identity. The name itself says that. Identity means, I said you that we should get the same number back. But in the previous case, it is additive identity where we are adding the number. Here we are multiplying the number. So for a number 10, let us say which number I should multiply. Which number I should multiply so that I can get the same number back, same identity back. Same identity back. So what I can say, for the number 10, I need to multiply with 1. I need to multiply with 1. 10 into 1 is 10. 10 into 1 is 10. 10 into 1 is 10. Only 1, right? You can see here. 1 is a multiplicative identity. For any integer A into 1 and 1 into A will give you the same number A. Minus 10 into 1 or 1 into minus 10 will give you the same number minus 10. Your answer will not change. Your sign will not change. Same number coming again, that is called identity. Here we are multiplying, so we say multiplicative identity. In the previous class we added, there it is additive identity. Right? So you can say that, for example, it's the same kind of example we can take minus 256 into 1 or 1 into minus 256. Both will give you the same answer. Both will give you the same answer minus 256. Both will give you the same answer. Same identity will reflect back. Multiplicative identity. We discussed additive identity, which is 0. additive inverse, which is for A minus A, multiplicative identity, which is 1. In the same way, we have next thing called the multiplicative inverse. The next one we say it is a multiplicative inverse. Okay, before that we have additive inverse. I'm so sorry. This is not additive inverse. Okay, this is a multiplicative inverse. This is a multiplicative inverse. That means we are multiplying. Additive inverse we have already discussed. For A it is minus A. For A it is minus A. Here it is for a multiplicative inverse. For the number A, you need to multiply with some number so that you can get 1 back. In additive, it is 0. In multiplicative, it is 1. So for the number 10, you need to multiply with 1 by 10 to get the value 1. So for the number 10, 1 by 10 is the multiplicative identity inverse. Or you can also say reciprocal. The same thing is also called reciprocal. Whatever it is, the product should be 1. Okay. For number 1 by 10, 10 is the reciprocal, or 10 is the multiplicative inverse. Minus 156 into 1 by minus 1 by 56 will give you 1. The same number should come here. Right? For a number A, 1 by A. A can be positive or negative. But we don't say multiplicative inverse for 0. Do you know why? For the number 0, we need to multiply with 1 by 0 to get the value 1. But 1 by 0, is it a defined value? Is it a defined value? No. For 1 by 0 is not a defined value. For multiplicative inverse will not exist for the number 0. Okay, this is very important. Multiplicative inverse will not exist for the number 0. The question is, what is a multiplicative inverse? What is a multiplicative inverse or reciprocal of the number 0? You cannot say the answer, you should say undefined. You should give me the answer as undefined, because you don't have the answer, you don't know which answer to keep there. 1 by 0 is not a defined number, right? So you can say that for multiplicative, for number 0, you cannot find multiplicative inverse, right? For rest of every number, for A, 1 by A. For 1 by A, they are reciprocals, or you can say multiplicative inverse, right? So the next we are going to discuss about, only multiplicative inverse of 1 is integer. Multiplicative inverse of 1 is integer. Why? For the number 2, what is multiplicative inverse? 1 by 2. Is it an integer? This is an integer, but this is not integer. For minus 2, minus 1 by 2. But is that an integer? No. But only for the number 1, 1 into 1 by 1 will give you 1. 1 by 1 is equal to 1. You can say that it is again an integer. In integers, only multiplicative inverse of 1 is an integer. The rest of all the integers, you will never get an integer back. Okay. And 0, just now we discussed, 0 does not have a multiplicative inverse. 0 does not have a multiplicative inverse, right? So I think all these are clear to you, right? In the next class, we are going to discuss about a distributive property of integers. Okay. Just the way we have discussed closure, next commutative. Let me once again discuss about these two. Okay, so that for a small recap. Today we have discussed about associative, and then we also discussed about additive inverse, additive identity, multiplicative inverse, multiplicative identity, right? Let me tell you what are closure and commutative just for your reference. Okay, so when we are taking closure property, if you have two numbers A and B, both are being integers. Okay, so we can say that A plus B is also an integer, A minus B is also an integer, A into B is also an integer, A divided by B may or may not be an integer. So closure property is valid for all these except for division. The same way we discussed about commutative property. Do you remember what is commutative? Commutative is again when we have two integers A and B, A plus B and B plus A. Are these two equal? I said in addition you can add in any way. Okay, order does not matter, right? It's correct. A minus B and B minus A, are these two same? No, these two are not the same. So subtraction is not valid for commutative. A into B and B into A, as these two are equal, again for multiplication it is correct, and A divided by B and B divided by A, both are not the same, again for division, commutative is not valid, right? So, all this we have discussed, and in the coming class we will also discuss about distributive property. Just let me tell you, okay, distributive property. So on this we are going to cover the next lecture, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, so today we'll be discussing about time, and time, as you know, is something which is very essential, right? In everyday life we keep talking about time, we keep asking what is the time, right? So we'll be discussing about that. So my name is Shashin Reddy, I'm a graduate from IIT NEET. Let's go into the class. So if I ask you, how do you define time? The question is, how do you define time or time interval? How will you answer? Right? So for that we have a very simple case, very simple definition. The interval between two instances or events is called time. Yes or no? Time taken. Time taken will be between two events. For example, I can say if you keep looking at my eyes, I might be blinking. Right? So between two blinks, how long it takes between two consecutive blinks? That is what? That is a time interval. That is the interval. That is time. And there are many such cases. Like how long? I mean, if there is sun rises once, the sunrise to sunset, what is the interval between them? That's also measured in terms of time. Sunrise to sunset, or from one sunrise to another sunrise again. From one sunrise to another sunrise again, how much time does it take? That is also what? That is also interval. We measure it using time. Yes or no? So there are many examples that you can think of. Interval between opening and closing of your eyelids. Interval between starting from your home and reaching your school. That also takes time. Interval between the start of a class and the end of a class or a movie. Right? So all of them are what? Are nothing but time. And what is this? That's a clock. And obviously we use a watch or a clock to measure time of the day. Yes or no? Good. That's wonderful. Right? So now when we talk about the units of time, very important, units of time, the SI unit of time is second. The SI unit of time is second. The symbol is small s. So you can write time as 2 seconds, 10 seconds, 15 seconds, 100 seconds, 1000 seconds, depending on the time interval. And do you know what 1 second is? What is 1 second? If I use a watch or a clock, anything. So you have three different hands here. You have a minute hand, a second hand, and hour hand. Yes or no? This is the hour hand. This is the minute hand, and this one that is moving here is the second hand or the second arm. So 1 second can be defined as the time taken by the second hand in a clock to complete one motion. Like one take, one motion is, see, here to here, 1 second, 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 1 second. So that is every single motion of the second hand is how much? 1 second. Clear? So you can define 1 second in that way, yes or no? Good. Now apart from second, do we have any other units of time? Everyone, do we use any other units? We have minutes, we have hours, yes or no? We have days, we have years, we have many such things. So let's go into all of them one by one. So here you can clearly see them. Now let's explain them all to you. So we talked about second. Second is the SI unit. But again we have other units. Let's say we have minute. What is 1 minute equal to? 1 minute is equal to 60 seconds. S will mean seconds. Then you have 1 hour. What is 1 hour equal to? 1 hour is equal to 60 minutes. MIN minutes. Right, MIN will refer to minutes. So 60 minutes. Now, can I write this as 60 into 1 minute? 60 into 1 is equal to 60. So 60 minutes can be written as 60 into 1 minute. And how much is 1 minute equal to? 60 seconds. So 60 into 60 seconds. 1 minute is how much? 60 seconds. So 60 into 60 is how much? 6 into 6. How much? 36. And you have 0, 0. So 2 zeros and seconds. That means it is 3600 seconds. So here we can clearly say that 1 hour, for 1 hour we use the symbol 1H. So 1 hour is equal to 60 minutes, or in terms of second, it is 3600 seconds. Clear? Okay, that's good. So we learned about minute, we learned about hour. Do we have anything else? We have a day. What is 1 day equal to? 1 day is equal to 24 hours. In 1 day we have how many hours? 24 hours. Yes? Okay, good. Then can I write this as 24 into 1 hour? 24 into 1? Right, and what is 1 hour? So 24 into 1 is 24. My mistake. And what is 1 hour? 1 hour is 60 minutes. 1 hour is 60 minutes. So 24 into 6. How much is that going to be? 6 4 24. 144. You can do the calculation here. 24 into 6. We are multiplying them. 4 into 6, 24. 2 carry. 6 into 2, 12. 12 plus 2, 14. 144. So 144 you have a 0. So 1 day is equal to 24 hours and is also equal to 1440 minutes. Okay. Then again this I can write as 1440 into 1 minute. 1440 into 1 is equal to 1440. The same. But what is 1 minute equal to? 1 minute is equal to 60 seconds. That means if I multiply 1440 with 60, or 144 into 6, 6 4 24, 2 carry. 6 4 24, 24 plus 2, 26, 2 carry. 6 into 1, 6, 6 plus 2, 8. That is 864, and you have 2 zeros. So it is 86,400 seconds. That means 1 day is equal to 24 hours. The same 1 day is equal to 1440 minutes, and it is also equal to 86,400 seconds. So that is 1 day equal to. Clear? Good? Okay, wonderful. So we learned about 1 second, we learned about 1 minute, we learned about 1 hour, we learned about 1 day. Good. You can clearly see here minute, done, hour, done, 1 day, 24 hours, 1440 minutes, or 86,400 seconds. Sir, should we remember it? If you ask me, I'll say practice it and then remember it. Because if you practice it, you will know how to find them and then you can remember it. So the complete steps are given here. You can go through them. Got it? Okay. Now you have 1 year also. What is 1 year equal to? 365 days. What is 1 year equal to? 1 year is equal to 365 days. Yes or no? In a year you have how many days? 365 days. So what is 1 year in terms of seconds? Not required. If you need, you can do the calculation. Okay. Then you have others also. Have you heard about a decade? Have you heard about a decade? Yes or no? What is 1 decade equal to? When you say 1 decade is equal to 10 years. What about 1 century? What is 1 century equal to? 1 century is equal to 100. You know about century in cricket. Century is 100. So when we say 1 century is equal to 100 years. Clear? So keeping that in mind, see, 1 decade is 10 years. 1 century is 1000 years. Then you have 1 millennium. What is 1 millennium equal to? Sorry, 1 century is 100 years. But 1 millennium is equal to 1000 years. 1 millennium is 1000 years. That's important. 1 millennium is 1000 years. Now if I go into this also, we have 1 century is equal to 100 years. Can I write this as 10 into 10 years? Because what is 10 into 10? 10 into 10 is 100. But what is 10 years equal to? 1 decade. So in place of 10 years, if I write 1 decade, then you have 10 into 1. So you can write decades. So 1 century is equal to 10 decades. Clear? Extra information which will help you. Then we are talking about 1 millennium. What is 1 millennium? 1000 years. But 1000 can be written as 10 into 100 years. What is 100 years equal to? 1 century. So it can be said that is equal to 10 into 1 century. 10 into 1 is 10. So it is 10 centuries. Clear? So 1 millennium is equal to how much? 10 centuries. Got it? Good. So you have 1 decade, 1 century and 1 millennium. Now all this is okay. All this is all that is clearly mentioned. Now there is one special case. When we discuss about the month February, normally February has 28 days. But once in every 4 years, February also has 29 days. After every 4th year or in every 4th year, February has 29 days. What is that year called as? That year is called as leap year because you are adding 1 extra day. So 1 leap year is equal to 366 days. After every 4 years, you get 1 leap year. Every 4th year is a leap year. And what does 1 leap year mean? The specialty is it has 366 days, 1 extra day. 1 extra day. Clear? Okay, that's good. So we learned about time. That's what we do in our day. Like every day, that's what we do. Now the question is, in ancient time, like very long back, how did people measure time? How did humans measure time long back? Right? How? That's what we'll be learning about. Now the first thing that people could observe is the day and the night cycle. It happens every day. So time can be measured in terms. I told you, right, what is time interval between two events? You can say from day to night is one time, and from night to day is another time interval, right? So we can say that sun rises and sets every day. So ancient people followed the day-night cycle to mark the passage of day between two sunrises. Okay, they also decided to stop working for the day when the sun set, because it becomes dark. So for them, sunset will mean they will not do anything after it. They will not work after it. But nowadays, we have electricity, we have current. So even at night we work. But that's not how ancient people used to do. Clear? Good. Then only days? No, we had other examples also. Other natural examples also. That is a lunar cycle. Lunar will refer to moon. Solar will refer to sun. Lunar will refer to moon. And what is the speciality of moon? If you look at the image, the shape of the moon, or the shape that is visible to us, the shape of the moon that is visible to us keeps on changing. You can clearly see. Yes or no? The shape of the moon. This is what? A full moon. It keeps on changing. So from new moon to full moon and again a new moon. Or from one full moon to other full moon. Or from one new moon to the other new moon. What is that? That we call it as a lunar month. So the moon to repeat itself. You are seeing one moon today. After approximately 29 days, you will see the same moon. It keeps on happening. So they call it as a lunar month. We also call it as a lunar month. Right? So the shape of the moon that is visible to us changes as it revolves around the earth. And a lunar month is approximately how many days? 29 days. So even people also used to measure time in terms of lunar month also. This many lunar months, 1 lunar month, 2 lunar months, 3 lunar months, so on and so on. So they had this sunrise and sunset or day-night cycle. They had lunar month. They also had other cases, which is seasons. And seasons were more important when it came to agriculture. Seasons, even today, seasons are very important when it comes to agriculture, when to plant a crop, when to harvest a crop, when to cultivate a crop, all of them. Clear? So each season comes once every year. Seasons, rainy season, winter season, summer season, and all of them, right? So they could tell a year, people long back, they could tell a year had passed if the same season came again. Now winter has passed. If winter again comes, it means it is 1 year. And the different seasons, right? Good. So now these were some natural examples. I mean, this phenomena, people found it in nature. Okay, people found it in nature. So look at a simple question here. Which of the following can be used to measure time? You have different examples. A flying bird, changing seasons, drying of clothes, all of the above. Which of the following can be used to measure time? What do you think? Yeah? A, B, C and D. The correct answer is changing seasons, because flying bird is random. We don't know for how long it will fly, after how long it will come back. But we know changing seasons, we know the exact time. One season has gone, the same season has again come, that means it is 1 year. Yes or no? The changing of seasons can be used to measure time. Drying of clothes, so in summer clothes dry quick. In winter they take much more time. Simple example I am giving you. Right, and it also depends on how much you have squeezed the cloth. So there are different cases which is possible, so we cannot say what it is. But seasons, they are regular. Okay, so changing seasons, yes, we can use it. Good. So now, ancient people long back, they did not have watches, they did not have anything like that to measure time. Now I have a watch. I can look at my watch to get the time. So what did people in the ancient time do? Now they also had instruments of their own. Okay, not as good as the watches that we use, but they had instruments. And one such simple instrument is something called as a sundial. What is that? You can understand that by looking at this. Or look at the image here. This is what it will be. So it all depends on the shadow. See, look at the shadow here. Now that shadow will change depending on this in the sky. Look at this. This is a sundial. The shadow of the sun. Can you see it changing here? Yes. So as the sun moves, the shadow moves. And as the shadow moves, we can say what time it is. What time it is. So this is called as a sundial. It works on sun. It makes use of sunlight. So sundial. It's a very simple one. Clear? So sundials were used in old times to measure hours based on the position of the sun in the sky. And oldest known sundial is from Egypt from around 1500 BC. What is 1500 BC? It is 3500 years ago. Long back. Very long back. Even then sundials were there. Good? Okay. Then again, there's an interesting fact here. Samrat Yantra. Samrat Yantra. In Jaipur. In Jaipur is in Rajasthan. The Samrat Yantra in Jaipur is the largest sundial in the world. So if you have a chance to visit Jaipur, please do visit this. And please do appreciate the construction. It is the largest sundial in the world. Good? You can see the image here, but please do visit Jaipur. It's a very interesting or very beautiful city. Okay? Okay. Then again, you might have seen this in many movies. You don't normally have this, but you might have seen this in movies. Right? An hourglass or a sand clock. It's very simple. There will be a specific time that the sand takes to fall down. So how much ever time it takes to fall down, we can record it. So you can measure it time. Now how much time does it measure? It depends on various factors. It depends on how large the bulb is, the size of the bulb, and how thick the constriction is. Different factors, and the quality of the sand also. Right, so time measured by an hourglass depends on the bulb size, the neck size. This is the neck. Okay, that is the neck. Everything else is the bulb. These two are the bulb. And the material, that is also the sand used, how soft the sand is. Ultimately, what is the thing? An hourglass or a sand clock is used to measure time. Got it? Good. Then we had pendulum clocks. Yes. What is a pendulum? You can clearly see that here. This is the pendulum. Can you see what's happening? It oscillates. A pendulum keeps on oscillating. Yes or no? And as the pendulum oscillates, here the second hand moves. Here there is no second hand. So gradually the minute hand and the hour hand moves. Okay. So the pendulum oscillates, and according to the pendulum oscillation, here the second hand, the minute hand and the hour hand move. In fact, to the other end, the time taken will be 1 second. Then again back 1 second. Then again 1 second. Then again 1 second. It's like a swing. Clear? That's a pendulum clock. And here pendulum clock, this is like a thread. This is like a thread or a string. And this is a heavy mass. Or which is heavy mass. That's it. Clear? That's a pendulum clock. Understood? Good. So even these were used. These are very interesting. Even nowadays they are used. Not regularly, but as a for showcase they are used. But again, pendulum clocks were used for a long period of time. That's why they are important. Okay. Then we have analog watches. The one that I am using now is an analog watch. Right. Again, nowadays technology improved. You have digital watches, you have smart watches. And to measure time, you can directly look at your smartphone. Yes or no? Or your device, any electronic device. You can look at your laptop also, desktop also, tablet also. So there are many such cases. And here we can see a digital watch. Nowadays we have smart watches. So digital watches are not used that much. Analog watches and smart watches are used more. Okay, understood? So that's good, everyone. So we have learned about time. We learned about different units of time. We learned about different measurements of time and how ancient people also used to measure time.